In this video, we're going to talk about a composition of functions. Now, before we get started, I've written a function equation, f of x equal to 3x plus 2. Now, if you recall, the domain is x and the range is f of x. So now I want to do a composition of two functions. Well, let's start with the x, and we're going to call this the domain of g. So then the range of g is g of x. Now, we're also going to call it the domain of f. So now the range of f is going to be f g of x. Begin to see a pattern for this? We have just did the composition of two functions. So, given two functions f and g, the composite function of f and g is defined by, that's the same thing as f of g of x. So the domain of the composition f and g is a set of all real numbers in x in the domain of g, where g of x is in the domain of f. So let's use the functions below to answer the questions. And then for questions A through D, we want to write the domain in interval notation. So let's start with the composition fg of x. So I'm going to rewrite it using the definition, and that is this. Now, similarly to order of operations, I'm going to look inside the function here, and that's g of x. Well, g of x is x squared plus 1, thanks to the above function equation. So now let's do f of x squared plus 1 on the side here. So that is the square root of x minus 1, but I'm going to replace x with x squared plus 1. 1 minus 1 is 0, so I have the square root of x squared, and the square root of x squared is x. So, composition of these two functions is equal to x. Now, the domain is the domain of the inner function with the entire composed function. Well, g of x is x squared plus 1. That's a quadratic function. We know the domain is negative infinity to positive infinity. The domain of a linear function, because the composition fg of x was equal to x, is also all real numbers. So the intersection of these two sets is also all real numbers. All right, so now let's do g f of x. So now I'm going to rewrite it using the definition of composition. Now, let's scroll up for a minute. F of x, because that's the inner function here, as you can see, is the square root of x minus 1. So I'm going to rewrite. Now, on the side, I'm going to do g of and the square root of x minus 1. Okay, I'm going to scroll back up, and we can see that's going to be x squared plus 1. So I can put in I'm going to scroll down now. Well, the square root of x minus 1, the quantity squared, is x minus 1. Add 1, they subtract out, that's x. So I can rewrite. Now, let's take a look at the domain for this. So that's going to be the domain of So f of x is square root of x minus 1. So we know that's going to have domain restrictions. So we'll write here square both sides and then add 1. So x is greater than or equal to 1. Interval notation, that's 1. That's included to infinity. Okay. So we know the domain of the composition gf of x is all reals because that's a linear function. So the intersection of these two sets is going to be 1 to infinity. All right, so part C, we're going to rewrite using the definition. J of x is the inner function, so I'll rewrite that. Okay. So on the side, let's do h of x squared minus x plus 2. Now, h of x says 3x minus 1. So that's going to be 3. Replace this trinomial for x. And again, don't forget the minus 1 at the end. Distribute the 3. And then combine like terms. So we know this. Now, I want to know what the domain for this is going to be. What's the domain of the composition hj of x? What's the domain of j of x? Intersecting with the domain of the final composed function. Well, j of x is quadratic, so we know the domain of a quadratic function is all real numbers. We know the domain of another quadratic function, that was composition hj of x, is all reals. So we know the domain is all reals. And again, keep in mind, this means that no matter what real number I plug in, we'll always get a real number coming out. Now, let's see if we switch the order of these functions, am I going to get the same answer? Well, let's write out the definition. So again, I'm going to scroll up. H of x is 3x minus 1. So now I'm going to do j of 3x minus 1. Well, we know that's from above, x squared minus x plus 2. So I'm going to rewrite. We'll do 3x minus 1, the quantity squared, minus, and then again, another x, going to replace it with 3x minus 1 plus 2. Now, let's do 3x plus 1 squared on the side here. That's 9x squared minus 3x minus 3x plus 1. Combine the negative 3x minus 3x. Here and here, that's minus 6x. So, rewrite. Distribute the negative. And then combine like terms. Oh, that should be a 2. So, you now know this. So you can tell switching the functions in this particular case give us two completely different answers for this. All right, now let's take a look at the domain for this. So that's going to be the domain of h of x intersection with the domain of the final composed function. So we know h of x is linear, so the domain is all real numbers. The domain of the final composed function, that's quadratic, so that is all reals. So this is all reals also. All right, so let's go to the next page then. Now, we're going to substitute numbers in, but we're going to use the exact same definition for this. So, I'm going to rewrite. Now, what is going to be the inner function for this? This is going to be h of 5. So I'm going to go to the h function first and plug in 5 for x. So 3 times 5 is 15 minus 1 is 14. So h of 5 is 14. Now, I only have one function left, and it's the j function. So I'm going to plug in 14 into the domain for the j function. So what is that going to look like? So this simplifies down to 184. So my final answer for this is 184. Now, I can certainly rewrite this as an ordered pair if I'd like. The domain of the original and the range after I compose the two functions. All right, so now let's try to compose three functions. So first of all, I want to write it out as such. Now, the inner function is f, so I'm going to put 10 into the domain for f. So let's do that here. Well, 10 minus 1 is 9, and the square root of 9 is 3. So f of 10 is 3. So I can rewrite g, h, and then replace f of 10 with 3. Now, what is the inner function now? That's h. So now I'm going to go to the h function and use the domain for 3. So that's 3 times 3. Don't forget the minus 1. 3 times 3 is 9, minus 1 is 8. So h of 3 is 8. So I'm going to replace h of 3 with 8. Now, there's one function left, g, and I'm going to plug in 8 into the domain. So let's do that here. Squared, don't forget the plus 1. h squared is 64, plus 1 is 65. So, composition of these three functions with domain value of 10 is equal to 65. Okay. All right. So the last thing that I would like to take a look at as I'm scrolling down. Now, suppose I give you the two functions. Can you write them out as two separate functions? So notice here, f of g of x is equal to x squared plus 1 squared plus 3 times the quantity x squared plus 1 minus 4. Now, what function is inside the other function on the left? That's g of x. Now, what function on the right-hand side is inside the other? That's x squared plus 1. So I'm going to have g of x equal to x squared plus 1. Now, on the left-hand side, what's the outer function? Outer function, f of x. What is going to be the outer function on the right-hand side? Well, if I can replace x squared plus 1 with a giganto x and another giganto x, looks like I have the trinomial x squared plus 3x minus 4. Now, I can check my answer with those. Well, let's do that. According to mine, I did x squared plus 1 for g of x. So now for my f of x squared plus 1, I'll do that on the side. And it looks exactly the same as the original. So I can rewrite hence we've come up with two separate functions so that when I compose them, I get exactly with what I started with.